Okay, let's see. All right, we got people here. Welcome to those of you guys who are live in person. Yay, that's awesome. We're still working out like the kinks and stuff, so obviously you still have to do some of your class on like Teams and stuff. I'm sure it was similar for your other classes today, where you were still kind of logging in. I don't know how everyone's doing stuff, but just for me to make it so that people are getting equal kind of access to everything, I'm trying to kind of run it that way for now. I'll play with some different ideas as we move forward, but for now we're still gonna have to like log into Teams and do the live version of class kind of thing. So there's that. And there's gonna be some just technology things that will probably become problems, and I'll try to fix them. So welcome. I hope your guys' first couple class periods were well, right? That they weren't totally nuts and that things worked. Those of you who are here in person, hopefully everything went okay with you finding your classes. You know, and for those of you at home, it probably felt very much the same as it has for the last like year. So tomorrow, hopefully you get some new experiences. For class today, we're going to be doing some practice exercises for section 10.1. I'm going to give you guys a link to a Google document that has our practice problems. If I remember how to do these, where did I put it? I put it over here. Yeah, I think this will work. No, what are you doing? There it is. All right. The link for this should be in the chat. If I did things properly, it should make you make a copy of the document. So hopefully it does that. If it doesn't, then we'll figure that out. So please make a copy of this document. It has our problems on there. I think, yeah. I'll do that. There we go. This is what the document should look like for those of you here. Make that bigger. And I'm going to share my screen so you guys can see what this is supposed to look like just in case. There we go. Awesome. All right. So if the link's not working, please let me know. All right, so we have our chapter 10, section 10.1, practice problems. I want you guys to work in groups. I'm going to try and use breakout rooms. This has not been very successful today. People don't really want to work together, but we're going to try anyway. And we'll try something different tomorrow. But today, this is what I have set up. So the first 5 minutes here or so, I would like you guys just to look through the document. Look at the different questions. There are 4 questions on here. All right, question 1, 2, 3, and 4. All right, there are kind of like answer spaces for you to type in your work. You can just type in your responses here if you like. You can type math by doing insert equation if you want to do that, and you get all kinds of nice fun math text. You can also just take a picture and upload it into a Google document like you probably have done in other classes. Right? So if you want to do work by hand, I do have paper over there for you guys that are in person by the hand sanitizing station. There's just loose paper. You can grab some paper if you want to use that. I do recommend doing some of these things by hand just for the practice. Probably gonna be easier. If you have your graphing calculator, you should be starting to practice using that, especially if you're taking the AP exam, because that's what you're going to be able to use. Using your phone or using like a calculator from Google, like just searching a calculator, isn't going to be the same. You need to know how to use the TI-84 graphing calculator. So if you don't have it, you should get it. If you do, start using it. If you do not have that to use, I recommend using the Desmos graphing calculator because it's going to allow you to type things in the way that they look a little easier. All right, so if you need a calculator, those are the things I suggest you use. All right, So I'm gonna give you guys 5 minutes to look through these problems. There we go. Where'd my mouse go? There it is. A couple other things first, though. I want to talk about 4-step process. All right. Many of you have not been doing all of this. Some of you have, some of you have not. You need to start using the 4-step process when answering questions. Right? And this is because it kind of outlines the things that you should be doing to get full credit for an answer on an AP exam. Okay, you need to, like, anytime you're being asked to perform inference, construct and interpret a C% confidence interval, carry out a significance test. Right? If you're asked, is there sufficient evidence for this conclusion? 4-step process. Whether you're told to use it or not, you should default to using it. Okay. On the AP exam, they're not going to say use the 4-step process. You just need to do it. Okay. So please think of that. Right? Unless the question says find the mean, right? Then you just do the steps to find the mean, kind of thing. Right here, I do have a couple of links here. There's access to the study guide for section 10.1. That study guide is in Canvas. This links you directly to it. Right, that has the formulas, definitions, and examples all in one PDF. Right. And lastly, we have a link to the AP exam formulas and tables. Again, this goes back into Canvas. I have that document linked in there. It is also a PDF. Right. You want to start familiarizing yourself with the formulas and tables that are on that sheet, because that's what you're going to have access to in the AP exam. Right. You're not going to be able to take notes with you into the AP exam. You're going to have that formula sheet and the knowledge in your head. You need to know how to use that formula sheet. It'll have table A, table B, and another set of tables that we haven't used yet. Okay, so we have those resources as well. All right, so we're going to give you all 5 minutes here, and then we'll get groups going using breakout rooms and other methods for that. So we'll put 5 minutes on the timer. All right, everyone, welcome back. Those are all closed. Awesome. All right, everybody. I know that wasn't enough time, obviously, to finish all 4 problems. Again, like I said at the beginning, part of the stuff that we're practicing here with like having only a certain amount of time is just to get a sense of how much that time feels like, right? Part of successfully taking like a standardized exam or AP exam is just having a sense of how much time is left and being able to budget your time well. So we're kind of just building that, knowing what does 30 minutes feel like when we're working on math. All right, so we're gonna go over the work and the answers for the first couple of problems. So you can see what that is. This is handwritten stuff that I'm going to show on the shared screen. So if you can't read what I wrote, tell me so I can clarify. So let me get this working. Yeah, and on here it shows up super light. I need like a new light bulb on my projector. I don't think it's been replaced in the 3 years that I've been here. So it might actually show up clearer on your shared screen on your computer, I'm not sure. Alrighty, so here we go. All right, so first problem here. We have the work and solutions here for that. Oh, that's what, yeah, don't worry about that. All right, so I want this. So again, something that I like to do when I'm solving problems is I typically start by just kind of listing all my variables and known values, what they are, the things that I'm going to need to use. I pull that all out of the word problem, out of the context, so that then I don't have to go back into the context and find it again. And it also helps make sure that I don't flip numbers or put numbers in the wrong spot if I'm going back in and out of the context over and over again. Just reduces the amount of mistakes I can make by doing it this way. Right, so I've got population 1 is the child mix, population 2 is the adult mix. Right, the population proportion of red jelly beans in the children's mix is 0.3, and for the adult mix is 0.15. Right? And then our sample sizes for the children, we have a sample size of 50 jelly beans. For adults, we have 100. Right? So this isn't necessarily for any one part of the problem, it's for all the parts. So notice I don't have it listed as part of my work for part A. It's just a separate thing. It's part of my setup for everything. So then question A, the distribution of the difference of the sample proportions will be approximately normal because now I have all the work. NC times PC is 15, right? The sample size, right, from here times the number of failures, essentially everything is not a red jelly bean. 50 times 0.7 is 35. Then for the adult sample, we have 100 times 0.15 is 15. 100 times 0.85 is 85. Are all at least 10. Right, that is our large counts condition. The large counts condition tells us that our sample is sufficiently large so that our results will be approximately normal. Okay, so we've checked that. That means the distribution will be approximately normal, and we've answered the question. Part B wants the mean of the difference of the sample proportions in our sampling distribution. Right, the mean of these two things, this goes back to chapter 6 now with our random variables. The difference of two random variables is the difference between the parameters. So we get 0.3 minus 0.15 and we get 0.15. Lastly, the standard deviation of the difference of the sample proportions. We get this crazy square root formula here, square root of PC times 1 minus PC divided by NC plus PA times 1 minus PA divided by NA, and we get 0.3 times 0.7 divided by 50 plus 0.15 times 0.8 divided by 100. Oh, I didn't share my screen. Thanks, Lolly. Sorry, guys. I swear I know what I'm doing. I've done this before once. Okay, you should be able to see my screen now, yes? I'm still adjusting to like having kids in school. I'm over here like using my projector in my classroom thinking everyone can see it. No, that's not true. Sorry. All right, so now you can see everything, hopefully. So yeah, here's all that work that I just beautifully described without showing you a picture. And we get the standard deviation is 0.07399. I kept a few extra decimal places on my rounding. If you rounded to 0.074 or 0.0739, that's probably all fine as long as you have shown the calculation. Right? As long as I've shown that I have the values and the square root and all this fun stuff with my solution there, with the actual end answer, the people grading it are probably going to be okay with whatever rounding you use, as long as you don't round to like 0.07. That's a little bit too little of accuracy. But you've shown that you know how to get that solution. You have the proper numbers in the right places. You're showing understanding. Okay. Is there anything I can clarify or explain on the first problem here?
What does that say in the parentheses inside? Right here.
Which one?
C.
A, B, or C?
C.
C. So
I can see the first one. I can't tell. See what's the second one.
This one?
Yeah, I could see the.
So it's 0.3 and then parentheses 0.7.
7. Okay, I know that one. That one's 15.
Parentheses 0.85.
Oh, okay, thank you.
Yeah, I know my writing it's a little small. I apologize.
No, I could see it, but sometimes it's too kind of blurry.
Yeah. So
it's fine. It's okay.
See if I can get it to focus a little better. Nope, that made it worse. Come on, focus. That's a little better. All right. Awesome. Any other questions about the first problem here? So then we're going to look at the second question here. All right, and now this is a confidence interval question. Once again, I've started just by getting all of my data up front. I've got my populations, 1 and 2, men and women, the sample sizes for each of those populations, and the sample proportions based on everything I was given in the context. All right. None of that is necessarily part of any of the solutions I've been asked for. It's just pieces that I need to use. All right. So part A here, I've been asked to construct and interpret a 99% confidence interval. There's an outlet right under my desk here. If you need to plug in there. Why is there? Stop. Okay, so that means I got to use a 4-step process. When you see construct and interpret, 4-step process. All right, so we want to estimate the parameter P1 minus P2, the difference of the population proportions, where P1 is the true proportion of men living at home and P2 is the true proportion of young women living at home. It's supposed to be young men and young women. At a 99% confidence interval. That is the statement saying what I'm going to do. All right. Notice I've said what I'm estimating and what the parameters represent and at what confidence level I'm going to be estimating it at. Those things need to be in our statement. So then we move on to the planning step. Right? If conditions are met, we will use a 2-sample Z interval for P1 minus P2. Okay. Most of the time, when you're dealing with proportions and estimating proportions, you're using a Z statistic. Right? With means, we use T, right? That T distribution, the T statistic. Right, so in this case, our inference method is the 2-sample Z interval for P1 minus P2. Our random condition, well, we were told in the context that our samples were chosen randomly, so we're good on there. 10%. Now this one I've worded in a slightly different way than I've shown before. There are more than 22,530 young men and 26,290 young women in the US. I got those numbers simply by taking the sample size and multiplying it by 10. And I multiply by 10 because 10% times 10 is 100%. So all I'm saying is that there's obviously more than these two amounts of young men and young women in the United States, and we know that for a fact, even though we don't know the actual population size. Okay. Since we don't know the actual population size, we can't necessarily check specifically that our sample size is less than it, but we can pretty much guarantee that it is. Lastly, our large counts. The number of successes and failures in both samples is at least 10. All right. And I'm making this statement because I know I have 986 successes in the men's population, 923 successes in the women's population, which means whatever's left over, which is definitely more than 10 because of the size of my sample, is our failures, so to say. Right? Both of those numbers are at least 10 in each case, so our large counts condition has been satisfied. Since all those things have been done, we now actually construct our confidence interval in our do step. All right. So here in my work here, we have a 99% confidence interval, which is 1% left over between each tail, which is 0.01 as a decimal. 0.01 divided by 2 gives me 0.005, which is the proportion for each of the two tails. Finding 0.005 on table A leads me to a Z of negative 2.575, which gives me a critical value of Z star equaling 2.575. You guys follow my logic in that and how we got to that Z star value, that critical value. So anyone need clarification? All right. So then we do this formula here to find our interval, right? We have the difference between the sample proportions plus or minus the critical value Z star times the square root of the standard error, right? And that is this craziness over here, similar to the formula we used in problem 1. Right, so that gives us 0.08655 plus or minus 2.575 times 0.013996. Obviously, there's a little bit of rounding going on in what I've written here, and that's okay. That gives us the interval 0.051, 0.123. So that means the interval is from 0.051 to 0.123. You should always list the smaller value first in your interval. It would be incorrect to write this as 0.123, 0.01, 0.051. The smaller value should always be listed first. So you're going small to large. Okay, so this is our interval. And then lastly, we conclude wait, wrong conclusion. That's the right one. Right. We are 99% confident the true difference of proportions P1 minus P2 of young men and young women who still live at home is captured between the interval 0.051 and 0.123. So between 5.1% and 12.3%. That's our conclusion. Now answering question B, part B, since the interval does not contain 0, since 0 is not a plausible answer, there is convincing evidence that the true proportion of young people who live at home is different for men and women. Now, I'm not saying whether it's a larger proportion for men or a larger proportion for women. That's not what I've been asked. I've simply asked, is there a difference? Does the evidence support that? In this case, it does, and that's why, because 0 is not a plausible answer. If 0 existed in our interval, then it would be reasonable or plausible that there would be no difference. In this case, there is a difference, so we're saying that there is. Right. If you start adding more details like there is a difference and our evidence says that there's more men living at home or more women living at home, you start adding more things, you're just giving yourself an opportunity to be marked off for something that you weren't asked. Answer the question, leave it brief. Don't give any extra details that aren't part of it, just answering the question asked. Okay. All right, and we're going to stop there because we're just over an hour here. We've looked at some problems, we've seen some solutions. The solutions to all 4 of the problems for 10.1 here that we saw today in class will be posted at the end of the week because I still need to use these problems for my classes later this week. So those will be posted by like Friday. There's also very similar type questions. I'm going to stop sharing my screen here. There's also very similar type questions in the practice problems and solutions in Canvas for section 10.1. So if you want other problems that are similar to these that you haven't seen yet, that's where I suggest to look. Other than that, we'll look at some practice problems for section 10.2 tomorrow. We'll look at those and look at some solutions and some work. And then I'll kind of evaluate if we're ready for assessments on chapter 10 or not. But next week, I'm still kind of planning on doing some AP prep stuff, so there's going to be a little bit of gap between more new content and what we did this week. So other than that, I hope you guys have a great rest of your day. Some of you guys I will see live in person tomorrow, and I look forward to that. I hope you have a great day, and we'll see you tomorrow. That's it. That's all. We'll stop it there.